Okay, so thank you to having me here and to giving me such opportunity to present my topic here in front of you. And I hope you get something new, you learn something from yeah, let's start. I mean, we are living in an excited age, right now. So these kind of messages like from Amazon, I just realized like when we've been on Javaland, like there come a friend of mine and say, okay, Amazon just kick off another 30,000 people. And Guardian has published an interview with a couple of these anonymously engineers. And I put the link here, you can read it for yourself. So, and they actually, it's incredible cycle. Like they are actually forced to use the AI for everything on all levels, and even when it doesn't work for the particular cases. And it's so rushed, right? In a way that manager wanted to have the overview. Like when I read this article, okay, that's cool. The managers wanted to manage their people. That's pretty great. But it may happen that actually their job will be replaced too, right? Because AI is actually identifying patterns. So more data you feed it, yeah. It's one part of my job roles is actually improve the models, like by using the AI. Like it feels like, okay, so you improve enough, just see you goodbye. Yeah, but I don't think it will be like this for a long time. Yeah, and I don't know about the bubble and so on. Nothing I can say about it. But I mean, something will be happening this year. And what I'm going to talk about today is evolution of design patterns, and I aim to give you the guidance how to actually use this tool, because this is not necessarily all the bad on it. Yeah. So just let's start. Everything is connected. Like since the physical energy principles underlying mechanical engineering to the advanced computer system controlling them. Yeah. So in our evolution, we just used lived experience and collective alignment to move forward. Yeah, this is how the evolution is done. And it seems like these days we are taking very different path, in some way very challenging path that is driven by interesting forces. So in this way, I really ask agent how much we do know about the universe. Is it 0.1%? And here apply me, okay, your guess is pretty humble, so we know even less. Although the scientists claim that we know actually 5% of all the matters, that still remains 95% we have no idea how the dark energy and dark matter works together. So, but actually it doesn't matter if it's 95%, it's pretty high percentage. So, yeah. And basically even when we have the 5 matters, there is still from this 5%, could be. So there's a 99% of our achievement we achieve as the humans is a mechanical engineered extension of our power, right? We love to build the tools that help us for do something for agriculture or moving, whatever. So we built up the tools. It's still 99%, yeah. And right now we coming up with large language model, and we let them to master our language, yeah. But how they did it, I will be talking about this, yeah. And what does it mean? And then we just create, because we find out that it's not enough to master our language, so we create a generative AI, artificial intelligence. And we created a chatbots or agents that can act upon these patterns that has been previously detected, in a hope that one day in a near future, I don't know what near means. It means this 2 years, 10 years, 5 years. So these kind of guesses are getting kind of different, across the industry leaders. So some days come general intelligence, artificial one, and it solves all our problems. We will be unemployed, but it will be working for us. Well, how it will be financed and how this is going to work, we still don't know. So humans are building the tools. That's true. So, but when we move to the LLM world, we actually move to the probabilistic world. Yeah, it's not deterministic anymore. So basically, on any level where you use the LLMs, it's a probability. Yeah, it's a pattern matching. So you cut the chain. So since that moment, wherever you use it in your system or your assisted advisors, so it's gone. It's not deterministic anymore. And also, the truth is that as there has been done, since there's so many investments on our way and so many promises about this general alternative information, so the market is driven by interesting forces, very powerful ones. You cannot work, but we can still use these agents, but they are actually, I don't know what's your experience, what is your level of education, not even level of the knowledge on the task you do, doesn't matter. Yeah, this is, right now I'm talking about probability. Yeah, I'm using the agent assisted helping me, the assisted coding. Yeah, and they are very sloppy, but they are incredibly fast. Yeah, on some particular task, approaches. I will be talking later about this. So they can produce so many interesting data, the results. They are extremely fast, and they can cooperate in a scale. Yeah, but they are actually trained on the past experience. So basically, what does it mean is the data, it depends on the data the model has been trained of, and the books and so on, they are actually old, right? So, but the agents are very fast. And as we're building a tool, why these agents works, why this everything actually works, is it's it's kind of activation function here that is the heart of the basically neural networks lying behind all these magic large language models. And it can hit a different form, but it looks like a sigmoid. Anyway, it's from -1 till 1, and it multiplies the equation that is lying. You will see later, and then it comes on the output. But it actually does the biasing, in my opinion. So it already, what does it mean? It actually cuts the extreme. So on the both sides. So therefore, I have been involved in multiple researchers during my university days on utilization of deep neural networks and perceptrons and multi-layered networks. So this is my feeling on it. But we keep building, and even when knowing this, so here I posted the report from late 25, like what actually, even when it doesn't work like a sloppy, like what we use for these amazing art. So there is a poll has been done, research, and it turned out that many companies, they are using for internal, external tools. Some of the companies don't even touch it and not even thinking for the reason. But what it remains true, basically is that employees are using it for assisted advices. I'm not talking only about the coders or developers, but I'm talking also about the project owners, management, just in order to verifying the hypothesis, in order to understand the topic, managers on very levels. So basically it's everywhere. But assisted coding is winning. So my name is Miro Wengner. So I think I'm more tool builders, engineer, scientist, and also thinker. Thinker in a way that if I get a hypothesis, it's required verification. Like having a hypothesis and great idea that works, nowadays it doesn't matter. Yeah, that's great, but you need to come up how to verify it. Yeah, more. So today, agenda, so like we go quickly, what technology lies behind these models, what it means, and what is the state of art of the research, and how can we actually use it for our purposes. And at the beginning, this is interesting, like when I talk about with the engineers, yeah, on the public about the AI, so people are not really aware what is behind it. They taking it as fundamental true that this tool is delivering something you want. Basically, it's like being in a church and believe in a God. No, that's good, but this is probabilistic. Yeah, and it begins with a kind of development of idea of perceptron which could replace the neuron. But as you can see, the activation function here, it's a core. Yeah, it's kind of multiplies the result, the linear function which is in the middle. Yeah, and it has no connection, no awareness about the context when it belongs. Yeah, that's very, because even when it is in multiple layer, not entirely. It's very comparable to real neuron, yeah, which we have in the cells. So although there's a research and it has a neuron, like each neuron is like a massive worker, yeah, it has not really direct connection awareness about what is lying in it, but it has an indirect awareness. So because in your body you have a frequency and energy, so you have basically your body is based on electrical impulses. So through these impulses on each part of the system, so that each neuron you have in the brain is actually getting the feedback. So this is very different story as the current marketing of the LLM are trying to claim. Like this perceptron guys will fix all our problems and develop the cure. Yeah, it's very, but we keep building. So we build up the multi-layer network, so we build up the transformers. Yeah, we develop the attention mechanism, so through the backpropagation algorithms. That's so good. With so many perceptrons are there without having no uncertainty, and we just believe that all we need is here. There's attention backpropagation, so, and it will fix all our things. Yeah, on late 25, actually, OpenAI and Anthropic release, finally, the research that they, agents and so on, actually prefer probabilistic satisfaction of the user based on the context to the truth. That's good. So what does it mean? Is when you read this, that actually, yeah, what you receive, it's your decision whether you trust it or not. It's your own. You are on your own, and but this is different to what the marketing says. Yeah, it's all probability, as I said. But even then, we are still aiming to kind of achieve this illusionary goal with the current state of art that we will reach the artificial general intelligence, and it took actually place in the companies' roadmaps, or not even companies, scientific and everyone who these believers, and it's there, it's real, and we are all counting on it that one day it comes. It is funny, right? You are doing deterministic decisions, but then you have there something which is completely unreal. Even it doesn't even sound right, but it's somewhere in the future which kind of oscillates over 10, 20 years. It's good to having built in the roadmap. So we keep up building, as we cannot have the AGI right now, so we are fun and lucky to have a generative AI. Yeah, we already identify the patterns. It's not hard. So I have been working on machine learning techniques and also implementation and utilization over entire my career, actually, as a software engineer. Yeah, this is where I get this. I was really proud when I was young engineer at Sun. Yeah, like when I received this skill, and this was very cool. Yeah, all we have built in 20 years. I was really proud. Yeah, because at that time it was really deterministic, and I was working on machine learning techniques and pattern recognition stuff on language actually, but it was still, even when the statistic and probability was used there, it was still very deterministic how we achieved it. So we can do this. I was really proud, yeah, to having this t-shirt. So this kind of thing, what we live right now, is completely very different story, yeah, and we have identified these patterns. Yeah, but right now with generative AI, we actually allow systems to act upon it. Yeah, so they have actually some action. Yeah, and even when we know it's not necessarily good, behaves good, so we kept building. So we try the approaches. We are the humans, right? So we know that LLM doesn't work. So in putting the rack on it, we give the function some reasoning. Yeah, it still hallucinates. So we keep our building. So we are, oh, you need to have a graph, Emma. So, but still, it's around the LLM. How the model, how the technology is built up around the LLM. It still kind of hallucinate. So, but we still try. So one agent doesn't work. So let's put it on a scale. So build more and even swarm of this. Yeah, but it's still, the results are sloppy. I don't know what kind of experience you all have, like based on the research. What I guess I didn't see any of articles with 100%, even on simple task. So no, none of those I have read. So maybe, like, I am not counting, is it black or white? Yeah, I'm not counting these kind of examples. So, and here what the research says. So interaction with the user, maybe you ask yourself, like, we have been having a rough day and kind of interacting with the assistant in order to achieve the goals, just close the Jira ticket, right? And you've been maybe thinking, okay, does it really help when I'm interacting with the agent too much and giving him more context and he's replying to me? Am I in a loop or not? May my new interaction harm it, or should I open the new session or just close this one? Yeah. So here is the research. Here are one of the research results. Yeah, it's recently posted. Like, I mean, maybe it was January even this year, or no, I think it was January or February this year. So what does it say? This thing is that actually responses from the agent, yeah, just keep in the context, the responses in hope that next iteration in the loop will be better. It doesn't matter, yeah. So it all depends on the model. Who is working actually here on developing the LLM itself? Like not the user, like a developer of the models. Is anyone here? Okay, so you are developing actually something like Anthropic or something like.
Oh, I do like fine tuning.
Fine tuning. Okay, that's cool. So you see here you are actually working on fine tune the model. So, but this is how the interaction with the customer. Would it matter to keeping in your memory the entire history? Oh, okay, it's good for you if you billing the customer for tokens, but it's not good for him because he needs to pay that. So, so anyway, we maybe ask, okay, because everything here is based on the mathematics. Yeah, it's like the evolution, the mechanical systems. So we were allowed to develop them because of mathematics. So maybe we get the idea, okay, how good are actually LLMs in mathematics? Can the LLM create new research topic? Yeah, they were actually in the past, I'm reading articles scientific over 20 years, yeah, right now. So due to my research and due to my work and so on, so I'm really interested into this. But this is the latest one of those. Yeah. So actually, what they're trying to do, okay, let's allow the agent actually to get state-of-art mathematical research, and let's ask the agent to create a new lemmas, actually new formulas for the mathematics, actually develop the math for us. That's a great idea, right? It's like artificial general intelligence. It's almost here. Yeah. And here, so that means he get fed by the data for ArcSIF. Yeah. And then he tried to formulate new lemmas, and actually verify the proofs, even the new one. And it turns out that actually current LLMs are pretty good in verification already known mathematical equations, yeah. But they horribly, okay, good. But what does it mean good? Yeah. So I mean 30% it's good, or 50 compared to 30, yeah. But they are not good that they can verify everything, yeah. So they are still sloppy, but way better than creating a new mathematical lemmas, yeah, that we will depend on. So here you see some achievements, but even when the Claude Opus for this is pretty good, I wouldn't like kind of trust to 35%, yeah. But the conclusion of the research that they are good to kind of evaluate already known for centuries proves that's great. Yeah, that's good information. But they are not able to create a new one. So we know we would love to use in robotics, right? Because with arrival of AGI, we get opportunity to have each of us our own robots. They will do the job for us. Yeah, they are so incredibly safe. So, and this is one of the, I mean, this research is 14 days or maybe for 3 weeks published. Yeah. So actually, how good are robots? And as one of those, again, there are many of such kind of researches, and it's very interesting. So, how good are actually the robots in safety, planning their next steps? Yeah, that's good. So they really think about what we all need. Oh, we need a fine tuning. You come into place. Yeah, you fine tune the models actually for the task. So we have a domain problem. So they create really complex scenarios, as you can see, but still it's a simple task. Yeah, they created. Basically, this was our arm, and the article, the research even ended that they have been not able to achieve in the safest scenario 100% success. Yeah, well, the arm was just moving. It's very cool. So that means actually that in complex tasks, there is actually, the conclusion is in complex tasks which requires more research. And this is just an example how far we are, how good we are in robotics. Even when we read in the newspapers, aside of how much employees got to lay off from automotive, yeah, how great idea they have to utilize the robots in production, yeah. So that's great, but this is the research. This is actually the facts, some of those, how it works, yeah, in real. So, but I may not have the actual data. So, and here is with arrival of AGI again. So we put our lives into the bet. So we let LLM models to analyze our medical data like time series. I've been on medical research for 6 years, so neurology. So, and I may tell you, just capability to detect abnormalities and the signal are very crucial. They can change lives, yeah. And here is one of those researches where they try to analyze the clinical time series. It turned out that just using the text-based agents, you don't achieve much kind of coverage of the data in abnormality detection. You don't get even the duration of entire abnormalities, and you are not scoring pretty well. Yeah. So, like, who will bet his life on 36%? Well, it's up to your choice, you know. So, okay, but current research It's very interesting. So as we cannot receive the enough context from the text, which has not really the context, on just adjectives can kind of modify the concept. So we use the images. That's a great idea. So the same technique, we build up the embeddings out of the images. Yeah, that's a great. Does Google is behind it? It's kind of have a more context, the image, obviously. So, and even using this super complex, again, fine-tuning scenario analyzing clinical series, turns out that using the images for analyzing clinical time series, you get the coverage 100% of everything. So you spot all these abnormalities. You have also the duration. So you are on 100 here. This sounds so great. But capability to evaluate it is still 45, almost 46%. Who will bet his life on 46%? I see not much hands. Well, it's surprising me. Maybe a researcher. Okay, you will have bet. Okay, I see one.
What do you mean by coverage or duration?
Okay, so you have abnormality in a signal, right? So you have multiple them on a signal, right? You are analyzing, and you need to spot what is the duration of each of those abnormalities. You need to perfectly detect them, and you need to spot all of them in a signal. That means, so with image you can spot all of them, even the duration, which is logical. You are going to screenshots kind of, yeah. But analyzing all these images, you get 45% success, like LLMs. So that's why I'm asked. So no, even this, you've been not betting your life on 46%. Okay, good to know. So, also that you may heard, actually complexity of the task matters. As the LLMs are really kind of beautiful tools for pattern matching. So that's what we've been using. I've been using it for the university. I think I have maximum 4 perceptrons, and I've been able to mimic the mechanical system pretty nicely. This kind of very small network was able to simulate the errors. Just the issue came into when I had to mathematically explain why this error is happening. Yeah, that's because it was hidden on the weight. So I get a beautiful neuron capable to simulate this task, but I have no clue how to mathematically explain this. Yeah. But right now, this happens with this perceptron on a very large scale, yeah. And it also means indirectly, in that as we are interacting with these models, task complexity matters. In abstraction level matters, yeah, because they are putting everything on a plane. Due to the pattern detections, yeah. So capabilities. So, and I know that you have implementing some reasoning algorithm, but facts reminds it's pattern matching over all the learned data in a plane. So you are searching the window. What kind of is match my input that I put into the system, and then you get back some kind of output. Yeah. It very strongly dependent, and the explanation why it is like this is a way behind the overthinking or chain of thoughts that the agent produce you as a proof that he actually did his job. Yeah, it depends also how much you trust to this. But again, you are saying yes or no at the end. It's not the agent. So I know the excuse is, it was the agent. He can apologize. He's very good on this. Oh, sorry. I know you have identified everything, but I'm sorry, maybe I didn't consider this or this. That's cool, but it's not the human, it's a machine, yeah? And he can be very good, and this is a very simple pattern matching and kind of rescue mechanism, yeah? It kind of satisfy you, but the fact that your system is completely broken is a different story. So then, as we keep trusting that this is our key, holy grail, yeah? As the same story on the research paper continue, it's kind of, I love my navigation system in a car, but I need to honestly tell you that once I use it at the beginning, I was not concentrated enough, and even in the known landscape, I ended up in the row, at the end of the road. Actually, there was the forest. And I was really not paying attention, yeah, just blindly following, just turn left and right, go straight up 200 meters, and that was the end, yeah. Yeah, that's funny, right? And I realized, oh wow, how this really works. And this is the same story, like people tend to believe that everything what LLM said is good, but it's still the pattern matching. It's very probability. It's not the search engine underneath data. It's not at all. Anything what is delivers to you is just a probabilistic match of the patterns of the data that has inside, yeah, of the token. So it's not the search engine. And what they done the research, actually, this is really disturbing. It's not publicly. It is not published, but this is one of those, again, researches. Yeah, they have, I think, from 10 to 20,000 people. They divided them on the three groups. One group used LLMs, one group used search engine, and one used just only brain. Yeah, 20,000 people, different level of education, different kind of work, assignments, and they kind of observed this group of over 4 months. It's a very small time window, depends on the time span you have, yeah, 4 months. And they kind of, this result is very disturbing because the people, the users, LLMs users, they completely lose their cognitive functions, yeah, they really outperform drastically. Like, I mean, you have statistically significant result, but this was like 100, this one of those 100% is kind of, whoa, yeah, they degrade the capabilities and in language, in visualization, in creativity, yeah, compared to other groups where you still need to connect the brain, yeah. So it's like a guy who is a top going to gym, and compared to a guy who is not going to gym, and both are expecting they could get muscles. Yeah, who's gonna get the big muscle? The guy who is not going to gym, or just the guy who is going to gym? Yeah. So there's the danger, and this leads me to question: who built this? Yeah, I mean, research groups. There is a mainstream narrative that Egyptians built this, but there is other proofs that maybe they don't. Yeah. So this is a question, but it reminds. It's a very precise structure. So many patterns work together. It kind of really determines it. It's mind-blowing to see it in the real. But what we are doing, we achieving this, okay, we're just rather, okay, it's too difficult. So we taking the probabilistic shortcuts in our thinking, yeah? And even then, when we are advising us using the advices assistant, yeah, right now we are losing this. We don't know in the moment how this, what's the length of the hole which is lying in front of us, because we can, even when we can see it, when we use the model, we need to see it's probable like this, and it's probably that deep, and may jump or may not, yeah. And having this implemented in multiple dimensions of our thoughts, so even when you are on legacy project which is built up over the years, I've been on one project that has been more than 30 years old. So there was a COBOL part, so awesome, built brick by brick, like the pyramid. Yeah, very nicely working. Yeah, and then comes something which comes probability here. So you cannot, this part may work or not, but it doesn't matter whether it works because gravity is still there. We are on planet Earth. So we can be very sure that gravity is present. So, and when we're using the same, so these LLMs are not necessarily guarantees that even the laws where the mechanical tools engineering are built remains the halt actually, yeah. There is a material implication, yeah, just two following processes, one of those. So we go even farther. So we have it here on each level. Everyone is using LLM because he wants to be faster in the hope that it will be. Even when it doesn't work, we came up with AI native patterns. Cool. It sounds very cool. Yeah. Basically, what me under the hood, we change our delivery process to discovery process. It's very cool, right? In discovery, it's already probability and stuff. But in delivery, you have to deliver. So right now we will be discovering things. And from the producer that actually we expected he produced something, okay, we made a manager out of him. So he is managing his all agents, right? And content just retired the facts became the knowledge, which knowledge itself already contains some kind of probability. It could be right or not, but yeah, we kind of hope again that we increase our productivity. And this is one of another research that has been published where actually it proves that that task complexity matters, and kind of on the creativity task, due to the nature of the element, it can actually boost your productivity, because if you are on a greenfield project, you have no idea, no kind of limitation, what kind of limits you have. You are discovering this on the way to the goal, right? So it may boost your creativity. Yeah, it actually again depends. Yeah, pretty much on the complexity. So, but here in the kind of a legacy project or already old, like mature project, mature, yeah. So it may even go into the negative scale, yeah. So artificial intelligence, of course, it will replace some task, some kind of activities. They won't be necessary because this tool is done for pattern matching. So you can get a boost on everything what is trivial. So you can know it. But the thing is, what I publish again, there is a trade-off. Yeah, if you get a boost here and you never learn this, yeah, you still need to be aware that you are removing your cognitive connections. And these 4 months removing your cognitive abilities, it does not go back in 4 months. That it's developed for years. Yeah. So that's very trade-off. You should think about this. Yeah, if I'm never learn actually applying the patterns or understand the limits, how it works. Yeah, I trying to perform with the help of assisted advices. It will not happen in that way. So you are losing actually you are losing your abilities. Anyway, you never have them, but you are still losing the other ones. Yeah, just doing a belief in this. So this is, and you will be what is essential, like to the abilities that you should remind is verification of your hypothesis, of your trust of the application. So, and this is very hard topic here. Yeah, but actually I wrote it by myself. Like it's logical, right? When the task is hard, it's very hard to develop and hard to verify, because you need to write the multiple test cases, but you don't need to write coverage of 100%. You really need to focus on particular test cases that are statistically significant to keep your application in production. Yeah, they are not all, but they are just kind of those. And ability to identify it is like a gold. Yeah, just to have it, because you don't have to have 100% correct. You never will because each day, each minute is kind of requirements are changing. We are agile, right? So requirements. So you cannot just keep up removing and adding a test, even with the agent. You don't know what to do. So this doesn't work like that. So maybe I'm wrong about this. Yeah, it may not work like that. Yeah, probability. So need to be precise. So what can help against actually to keep you still fresh? Yeah, it's actually kind of, even when this world is right now based on probabilities, you may not have the probabilistic background like a study does. It still remains very like a gold here. Keep your deterministic knowledge and principles. Yeah, you need to have. Well, you don't have to, but it's helpful to have some kind of patterns here that is deterministic. You actually know how you went from point A to B, following A, B, and so on other points. And these principles are there here for a very long time, and maybe they not have been read explained properly at the universities and the school, and so how I should read it in the age of AI. Yeah. So as I said, we have the AI here for pattern matching. It's very great. It's actually very good to kind of create the ideas, not because I don't care whether it's necessarily true or so on, but I would love to push my idea, kind of do the construct, whether it may work or not. So I'm having kind of abstraction of my idea. So I have right now kind of behavior I would love to have here. So I'm aware of. I don't know how it connects all together to the sphere of knowledge I have been publishing at the beginning, but I still can keep going, and I can kind of create the interfaces around this idea and separate it in the small points, and kind of then I can really encapsulate with my thinking what to do, and here can it be helpful. When it's still going the other way around, when I'm implementing all these, so I first need to start with encapsulation, actually the point points. I cannot like start building a house from the top. Well, it never worked. I never seen it. You can draw it on a paper, but it's not the product you would love to have, right? The papers and PowerPoint is a very different story here. So in a real, you're building house from the ground, right? Or in the games on a computer, you can still build a house from the top. So, but in real, again, from the ground. So I guess it's still valid. So, and this is the same kind of approach. And on this way, please don't repeat yourself. Yeah, even when you are doing these assisted advices. So you need to really start to encapsulate your kind of ideas or kind of elements, and then just keep inheriting them, because it's changing over in a time how you keep developing. Yeah, don't start with the abstraction, the development. It's like way to the hell. Yeah, so you never get up and you introduce some. Just my recommendation. Yeah, you can follow whatever you do, but I would start with very small step. And you maybe heard about this solid, but actually for me it's like a solid principles are kind of a result of what I have before on the slide before. Yeah. And it's kind of good guidance, and it's end up again on the please don't repeat yourself. If you feel that you need to repeat, please abstract, inherit, and do all these. Because if you don't, you go to the world of anti-patterns. There are so many, and it's even growing. One of those with hallucination and with assisted code is they are even new ones. No one knew about them before ever, and even not realize that it may happen. Yeah, and they are more complex. So these kind of machines are so much faster than you, and they can hold the context in a way that you are not capable of. So your context window is very small. Yeah, and you cannot, you even when you are a woman, and it's sometimes said that women may operate in parallel tasks, is not true. It's scientifically not true. These women are capable to just adjust small multiple tasks in order. You're way faster than the men's are capable of. It's a kind of evolution development, because they had to take care about the kids, so they had to put this. So we as a man may not have these capabilities, yeah. So, but the truth is, the research says we're really intensive that there is not such kind of like thinking about in multiple dimensions, yeah. So we have one brain. That's all. So, but here we have anti-patterns caused by the hallucination, and how to even address them. And they are actually making some difficulties to intercommunication. They are actually introducing the bottlenecks on many different layers, not even development. So they are actually introducing bottlenecks up on the level of the stakeholders that they may have. And they may have a very different information, yeah. But we are just let us self-advise by ChatGPT or something, so in a hope that we will fix it. No. So they remind. They are projecting in the cost of the project. And what is amazing, I thought that this thing will be gone, because when aside of this, I'm been contributing to OpenJDK on the performance level. This kind of autoboxing would be on a Java's just kind of away. No. So if you kind of let yourself advise by the assisted coding, so you get about a lot of these, depends on the complexity, and they will be beautifully hidden on a way, because what is beautiful on this, like what is beauty of using the pattern matching, right? So the patterns, basically the text they are learned on, yeah, they not necessarily guarantee that the answer that you get is right. So they don't care about the patterns at all. They just use only the data they know about it, how the result may differ. So that means that actually the result may include multiple patterns kind of smashed together. Yeah, for AI it does not matter at all. Why? Like it's your belief that it's true. Not his. He's doing a pattern matching. He's doing just mathematical job, probabilistic one. So, but it appeared to me that many of the results are affected by this. You don't want to have it in production, not at all. So, because in production, in a cloud, so you pay for a cycle, computation cycle. Everything is actually back calculated to the energy you consume. Yeah. So each feature you can pay for Amazon, Google, whatever provider you are on. So it's back calculated to the energy consumption. So, and if you have this, so you are basically like, you are throwing in a big scale the money out of the window. By your company money, actually. So, in hope that your company will survive long enough. So, here one more thing. These agents are, this really, increase my attention, yeah, when I get the assisted coding generated code, like I let the agent operate on very particular kind of code, not in a big scale. So they simply would love to introduce the new libraries, whatever they get the information out of it, yeah, instead of using the known API on the platform itself, on the Java. So they rather sometimes introduce the libraries, even when it is already in the JDK itself. This is very cool. So you need to really pay attention what you get into. So aside of security holes and memory leaks and whatever you may introduce, yeah, in a big scale, again, in a big scale, that you lose your control because you have still one brain. Yeah. So this is the other fact is you may be using some kind of wrong tools there, even when it used the one. So instead of the hash set, it used the array list, where you see the complexity on the task, and it will be very nicely propagated. And if you are not experienced or with the profiling tools, and you don't have even implemented this in your workflow, so you will not discover it. Yeah, and if you are using the framework, this kind of particular case will not be displayed like this. Yeah, and it will not be visible if your load of your application is not high. And what is a high? Yeah, it depends. Yeah, many companies, they don't even doing the evaluation of the load. Yeah, of the product. Just they don't care. They just hope. Like this is the same thing. Like we hope that LLMs is delivering us the good food. Yeah, good. So we are in a religion here. So, yeah. Yeah, that's cool. So anyway, even when we are using here the standards, so as they are inevitable, and they are inevitable in a way that actually the pattern matching tool is delivering kind of patterns, yeah, as an output. So we still, in order to be able to communicate with this tool, we need to deliver the standards to them. So that means you may increase the chances that you may get out the proper response or whatever hoped response. So by using the parents already in assisted advices, and their pace really Pareto principle is kind of common. It's a kind of proven that it works like this. So if you are not using patterns on 20% of your code, that's cool in a core, but 80% not. And if you let the LLM just kind of read this part of code, so what kind of guess is you get? So you may probably get in 20% of your interaction with the assisted devices, you may get 80% of trash. Yeah, due to the facts or based on your previous work. Yeah, because it's, again, pattern matching. So it also means that concurrency is inevitable on any, I've been pretty sure who is not working on concurrent stuff, who is not using framework for his job as a developer or just project who isn't. So there will be zero hands on. So we are all using frameworks and they are already introducing the concurrency models. So you don't have to think about that. So you maybe use in Java or Spring or whatever, even in the front end, yeah, React or something. Although in the front end it's very difficult to talk about concurrency, but they have kind of a weight and so on. So on other perspective, on other languages and platforms, well, we are here on Java, so concurrency is actually there already, even when you don't know about the concurrency. But again, interactions with the agent-assisted coding start at the beginning. So first, I would say, get your shit right. So that means create your object, feed your tool with proper kind of abstraction here. So start from creating that one, yeah, because it helps. Because if you don't have under control how you actually created this, how the agent should know about that. He's not reading the mind, not yet, but even if that would be, it's a still probabilistic tool. Yeah, I would not let probabilistic tool read my mind. Yeah, so, and if you get it right, you can test it. It's like a step forward because the pattern matching tool already know what kind of patterns could be matched. So you can use in your favor in a work. And if you have it done, you need to go, the next step is the structure itself. Yeah, how to do this. Please don't push it. If you push too much, yeah, on the development, or if you have not pushed to kind of maintain this, you will get the kind of sloppy answers and sloppy recommendations, and you need to really take care about how to using the internal tools. And if your colleagues or whatever, whoever don't have it, so that's very difficult to utilize the current state-of-art LLMs. They will not always work for your favor. That may not be really productive. So, and then you go behavior, yeah? At the end, and you get some behavior, you do have a concurrency model and so on. So following this kind of interaction with assisted coding would help you with, I'm not saying 100% because it's probably help you, yeah, but you increase your chances. Yeah, that's good. You increase your chances, yeah, not just get job done. It's still on you, yeah, even when your belief that agents are doing well, good job. So anyway, back to the 2018, the Forbes done the beautiful study in American market. So they evaluated the price of the bad code produced every year. It's $300 billion. So I'm a poor guy, so I would love to have a part of it. Yeah, I would gladly refactor and help to avoid it with my knowledge. So anyway, so it's very nice because then comes in the 2022 just utilization of LLM models. So you go way more because the hallucination comes here. So we had already these 300 billions here, yeah, and hallucination of the API are like who thinks makes the situation better. Okay, I conclude that the rest is not. Yeah, it's it's not making the situation better, right? It's kind of hallucination or completely we are losing capability how to address this issue, and it's happening on all levels. So we on the configuration, yeah, like it was very funny. Who was affected by the outage of Amazon services for a couple of I think it was 18 or 16 hours it was down. I mean, they can calculate it in billions or millions. I'm not sure, maybe it's even billions. I have a pretty good number because in industry, in real one, when you have dependent system, you are really paying a lot for that. So, I mean, they should more thinking about not how to buy the new GPUs, but actually how to make their infrastructure reliable. Because there are big companies, even including probably some medical ones like hospitals and so on, depending on their services. You cannot afford, like you have a patient, right? Like auto accident, so he was dying in the next 5 minutes. So, and you get display message from the agent. I'm sorry, I'm right now out of the order. Please wait another 13 hours. But he has 5 minutes. So that's good. Yeah. That's black humor, yeah, but I think on these 13 hours then they went down, and it's not just like Microsoft has the same stories, yeah. When they are down, some lives may depend on it. So, but we still live our alternative information. Thank you, Venkat. Alternative information dream that it works one day came true. So, okay, how to address the alteration when everything is kind of not even visibly going down. So yeah, we are humans building a tool, so we get to, you need to improve your prompt engineering. That's great. So you're stuck in the loop and you have no idea how to get out of it. Like how to, you may fine tune, that's great. But actually research, so it doesn't matter much. Yeah. So there are the data. It matters for particular cases. These particular cases are very specific and research is done on it, but actually benchmarking depends on which kind of how you implement the benchmark. It's still as a kind of isolated environment, yeah, where you do the benchmark. You cannot kind of generalize these results on the whole market where you're gonna use it, on all use cases you're gonna use it. So you need to be careful about how you read actually the benchmarks. They are often used in marketing, but they have some kind of specific, yeah. And you need to be able to read it, what kind of these benchmarks are saying and how they are used. Okay, aside of it, I wouldn't trust many of those benchmarks, how they are done. You need to incorporate some additional knowledge and model improvement. What does it mean? I don't know. Yeah, but it's kind of how we address it. Yeah, here they actually Forbes kept doing this, and they kind of investigated what is the price of this kind of bad code, the hallucinated code, and you see the numbers are not consistent. They are plus minus 10%. Maybe they can even. It actually in probabilistic world it doesn't matter if it is plus minus 10. So I don't care. It needs to reach the significancy, yeah, this number, when I can react upon it. If it is below this threshold, so I don't care. So, but for us, as we are living here in real, like 20% is, or 30 or 40, it may have an impact. But it may not reach the statistical significance. So so from PowerPoint perspective, it doesn't reach a threshold, so I can omit this. And I just communicate some very nicely message, like an agent. I'm sorry, I have been wrong, but next time you should define this better, my prompt. Okay. So, but turns out it may really kind of reduce the productivity over 30%, go really easily. So after all these readings and research and even interaction, it's still the human remains the center of everything. So you will be at the agriculture, yeah. So I mean, I would love to have an apple. That's good. That's good. Like my son is telling me, yeah. Even please, can you give me apple? Yeah. So even when I go to the shop to buy apples, right, there still needs to be someone who actually kind of maintain the trees, right, and take care about these trees. Even when I have it at home, like in a garden, the tree, so I'm taking care about this tree that it can produce the apple, yeah. So, but there is a catch in this, because I just show you that actually the degradation of your knowledge, of your cognitive abilities, yeah, are in stake here. If you are using these LLMs, so you need to do the trade-off and just mental exercises or whatever, meditate upon it, yeah? Because you don't want to be losing the exercise. If you are young guys, there are a couple of those, or I consider myself still young, yeah? So I don't want to lose my mental abilities, yeah? So what does it mean in this? Brain is a muscle. Yeah, if it degrades, that means actually, so your part, it controls actually all your system. So there are many sensors of these. So, and when the system keeps crashing and you are not aware of it, so it will keep crashing over the line. And you see what the result was after 4 months of intensive using. So that you can do conclusion for yourself. So my takeaways here is the one important is like really train your brain as like a muscle. And task complexity, you are interacting with it. It actually doesn't matter. And if you have no capabilities with the topic, which are maybe most of the time case, because we don't have a superhuman that has studied all branches, like he's at the same time super great mathematician, at the same time physician, mechanical engineers. Oh, we had Leonardo da Vinci. This is concluded to be, but it's a guess. I don't know. Yeah. So, but I don't know such many of those people. Yeah. So please train your brain as a muscle. Observe and validate, because this is actually matter in the probabilistic world. Because this is how we've been doing this in the past. But in a way, to use the tool we have possible right now, you really need to be kind of able to evaluate the certainty whether it works or not. And the level of abstraction you are asking. It's incredible. And here comes level of education, whether I am able, rather not trust yourself. Yeah, it's better that, because then it allows you to not trust also the LLM. But if you trust yourself too much, yeah, like self-confidence, it's great. It's great. And these agents will only support you in self-confidence because they are designed to like feed sugar, you know? So it's like to being on a cocaine all the time. Yeah, it's like extreme productivity, extreme achievements. And you can ask agent, he will only confirms to you. Yeah, that you are doing a great job. It does not correspond with the reality, yeah. But you want to see it anyway, so it's okay. So please be aware of it, that these tools are probabilistic. They have nothing to do with determinism. So this activation function, that is the core of everything, is actually there because of introducing creativity process, we call it, the nonlinearity. And in this moment when it happens, there is no way back to determinism. Yeah? Thank you for all of this. And I'm publishing the JC AI news, everything what is it. There's so many research, kind of even more disturbing videos with the Nobel Prize winner, Jeffrey Hinton, and our Google guys and so on. So you can check it out. I just collect, with the help of other Java champions, collecting these news. You can stay in touch with me. You can contact me, ask me any question you want. I try to give you the honest probabilistic answer. Well,
sure your email is gmail.com?
Yeah, exactly. You see, I ask agent to write it. No, I'm just kidding. It's my failure. Agent will be right in the simple cases, but I can correct it. Thank you.
That's
Oh, this is